things. Yesterday I was yesterday we were dealing about seepage pressure. Yesterday we were dealing about seepage pressure. So same thing I will continue. So as I told you, seepage pressure is because of the water which is standing and the direction of direction of flow decides whether to for calculating the effective pressure you have to add this or subtract this. So after explaining this one, I told you seepage pressure is given by H into gamma W because to what head it is there, and gamma W is the definitely unit weight of water. So I will divide this by Z, multiply by Z. So H by Z is I, hydraulic gradient, you know it very well. Z is the height, gamma W. So this is the formula for seepage pressure. PS is equal to I into Z into gamma W is the formula for seepage pressure. So after that, I explained here what are Z, I, all these things. So force is given by pressure into area. So pressure you got this much into area. So force per unit value means divide by volume, Z get cancels. So force per unit volume is given by I gamma W. The seepage pressure always acts in the direction of flow. In the direction of flow. Suppose if the flow is upwards means seepage pressure is also upside. The vertical effective pressure may be increased or decreased due to the seepage pressure depending upon the direction of the flow. Thus the effective pressure in a soil mass subjected to seepage is given by this one. This is the figure they have explained this got this formula I is equal to G minus 1 by 1 plus E. So how you got this one, that also I will explain. One more derivation is there here. Okay, so the effective pressure is given by sigma dash is equal to Z gamma dash plus or minus PS. So when to take plus, when to take minus plus? If the flow occurs in the downward direction, the effective pressure is increased, means you have to add it. And if it is in the upward direction, that have to be decreased. So now what is upward flow and what is quick condition? I told you quicksand condition is a special condition. When flow takes place in an upward direction, the seepage pressure also acts in the upward direction and the effective pressure is reduced. When the flow takes in the upward direction, so seepage pressure also acts in the upward direction and the effective pressure is reduced. If it is acting downwards, effective pressure is increased. If the seepage pressure becomes equal to the pressure due to the submerged weight of the soil, effective pressure becomes zero. मतलब ये जो Z into gamma dash है, ये और ये दोनों same हो गए, so this minus this becomes zero, and when this becomes zero, effective pressure becomes zero. And when effective becomes zero, in such a case, a cohesionless soil loses all its shear strength, and the soil particle have a tendency to move up in the direction of the flow. This phenomena of lifting of soil particles is called the quick condition or quicksand. It is somewhat similar to liquefaction of soil. Liquefaction of soil you will learn in the higher classes. Liquefaction of soil काय होतं माहिती आहे, जे effective stress आहे sand मध्ये totally zero होणार आणि zero झालं की liquid होऊन व्हायला सुरू होणार, and this happens during earthquake conditions. So quicksand condition is also same here. Here also effective pressure becomes zero. Effective pressure becomes zero केव्हा होत आहे, केव्हा submerged pressure आणि effective pressure दोन्ही same झाले, plus and minus होऊन equal to zero होते. So this is the formula. Here figure he has given. So sigma dash is equal to effective pressure is equal to Z gamma dash minus PS, that is the seepage pressure, and this equal to zero. When this becomes zero, PS is equal to Z gamma dash, or I is equal to PS is given by I into Z into gamma W equal to Z gamma dash, or I equal to, that is the critical condition, this Z get cancels, IC is equal to gamma dash by gamma W, and if you take the formula for gamma dash gamma W, you will find this one, and this particular condition of hydraulic gradient is called critical hydraulic gradient. So you remember the formula, critical hydraulic gradient is given by G minus 1 divided by 1 plus E. G minus 1 divided by G plus E. So here also it is derived in the same way. So same formula is there, derivation is there. So you remember IC is equal to, that is critical gradient is equal to G minus 1 divided by 1 plus E. G minus 1 divided by 1 plus E. So in this topic, in this slide, what you learned, once again I will remind you, first of all you should know what is meant by seepage pressure, what are its formulas, and when it is increases, when it decreases, that is quicksand condition. So when quicksand condition is there means the pressure and seepage pressure becomes equal but with negative sign. Therefore, such cases effective pressure is zero, and when effective pressure is zero, such condition is called quicksand condition. Such condition is called quicksand condition, and the corresponding hydraulic gradient is called critical hydraulic gradient, and that critical hydraulic gradient IC is given by this formula, that is IC is equal to G minus 1 divided by 1 plus E. G minus 1 divided by 1 plus E. G minus 1 divided by 1 plus E. Okay, so this is all about this. Not this is, I mean, from the examination of point, they may not be that much important, all these topics, but you should know about this one. In gate examinations, it is important. But from the university exam, they will ask generally the questions from permeability only. Questions from permeability only. So now one or two problems we will find out. So remember critical gradient, critical hydraulic gradient IC is given by G minus 1 divided by 1 plus E. What is critical hydraulic gradient? This happens when effective pressure is zero. When effective pressure is zero. So this is given by G minus 1 divided by 1 plus E or gamma dash divided by gamma W. How it comes, I will tell you. Write the formula for gamma dash, write the formula for gamma W. You will find this one. Okay. Now you take down this question. A coarse grained soil has a White's ratio of 0.78. Means E is equal to 0.78. A coarse grained soil has a White's ratio of 0.78 and specific gravity as 2.67. G is equal to 2.67 and White's ratio E is equal to 0.78. E is equal to 0.78. G is equal to 2.67. Calculate the critical gradient at which quicksand condition will occur. Means IC is equal to how much? So IC is given by gamma dash by gamma W or G minus 1 divided by 1 plus E. IC is equal to G minus 1 divided by 1 plus E. IC is equal to G is 2.67 minus 1 divided by 1 plus E is 0.78. If you simplify this, it is 0.94. Remember, this question generally asked in the examination. So you remember the formula for critical hydraulic gradient, and it is given by G minus 1 divided by 1 plus E. That is 2.67 minus 1 divided by 1 plus 0.78. So 1.67 divided by 1.78, it is 0.94. 0.94. Got it? Next. Find the value of critical gradient for the soil having its specific gravity equal to 2.68 and White's ratio 0.87. Please do it yourself. Without seeing, you do it, you will find it. Same problem is there. Find the value of critical gradient. And remember, this has been asked many times in MCQs. Find the value of critical gradient for the soil having its specific gravity equal to 2.68 and White's ratio equal to 0.87. Find the value of critical gradient for the soil having its specific gravity equal to 2.68 and White's ratio equal to 0.87. Okay, Nikita. 0.9. Yes. GIC is equal to G minus 1 divided by 1 plus E, 2.68 minus 1 divided by 1 plus 0.3. अगर से इसमें आपको कुछ भी याद नहीं रहे तो आप थोड़ा बहुत फिर मैं बताता हूं आपको। सीपेज प्रेशर का डेफिनेशन देख लो, उसके बाद अपवर्ड फ्लो कंडीशन क्या है, क्विक सैंड कंडीशन क्या है, यही पूछ सकता है डेफिनेशन में, और हाइड्रोलिक क्रिटिकल हाइड्रोलिक ग्रेडियंट क्या है, और क्रिटिकल हाइड्रोलिक ग्रेडियंट का फॉर्मूला क्या है। आईसी इज इक्वल टू जी माइनस 1 डिवाइडेड बाय 1 प्लस ई। नाउ यू टेक डाउन दिस क्वेश्चन। The specific gravity of the particles of a sand, the specific gravity of the particles of a sand is 2.65. The specific gravity of the particles of a sand is 2.65. The porosity of the sand in a loose state is 0.52. The porosity of the sand in a loose state is 0.52 and in dense state is 0.37. 0.37. Find out the values of the critical hydraulic gradient and in these two states. यहाँ पर पोरोसिटी दिया, दोनों केसेस में दिया, दोनों केसेस में दिया, और दोनों जगह आपको क्या करना है, क्रिटिकल हाइड्रोलिक ग्रेडियंट निकालना है। You have to find critical hydraulic gradient. तो यहाँ पोरोसिटी दिया तो आप White's रेशियो निकाल सकते हैं। White's रेशियो n is given by E upon 1 plus E। तो पहले लूज स्टेट करो, फिर ड्राई डेंस स्टेट करो, और दोनों केसेस में आईसी का वैल्यू निकाल के मुझे बताओ। प्लीज डू इट। समझ में आ रहा है क्वेश्चन? समझ में आया नहीं? देखो पहले नहीं आया तो पूछो। डू इट। First you do it for loose state, then you do it for dense state. Just do it, please. First loose state you take, n is equal to E upon 1 plus E. N is given for loose state as 0.52, E upon 1 plus E. From this you calculate E. From this you calculate E. From this you calculate E. Okay, once you calculate E, which is 1.08, then IC you calculate. IC is given by, that is critical gradient is given by G minus 1 divided by 1 plus E. IC is equal to G minus 1 divided by 1 plus E. Okay, Nikita. 1.08 and 0.79. Yes, White's ratio is 1.08 and critical gradient is 0.79. This is for loose state. N is equal to E upon 1 plus E. So in loose state, 0.52 is equal to E upon 1 plus E. Simplify karo, 1.08 aata. Critical gradient is given by G minus 1 divided by 1 plus E. On simplifying, you will get 0.79. Same thing you do for dense state. For dense state, N is 0.37. Find E. After finding E, find the critical gradient for dense state. Okay, Mansi, second statement point. Very good, beta. Karo, sabhi log karo. You find the critical gradient for dense state also. Please remember, this is the questions asked in MCQ. Okay. So now I have to complete the syllabus as you are having university exams. I think in the first or second week of January, most probably first week or second week. So anyway, I have to complete the syllabus. Yes. So still 3 units are there. आज कल में ये हो जाएगा. तो 3 units कौन से किया मैं? फर्स्ट चैप्टर किया, कॉम्पैक्शन किया, परमेबिलिटी किया. अब बचे कौन से? स्टिल, shear strength, consolidation, earth pressure. अभी 3 चैप्टर्स. हाँ, you take down this question please. Sand lying below a masonry dam. Please take down the question and देखो मत पहले. आप खुद ट्राई करने की कोशिश करो, खुद सॉल्व करने की कोशिश करो. Sand lying below a masonry dam has a porosity of 40%, N is equal to 40%, and a specific gravity of 2.67. And a specific gravity of 2.67. Determine the maximum permissible upward gradient. Determine the maximum possible upward gradient if a factor of safety 4 is considered. Once again, I will repeat the question. Sand lying below a masonry dam has a porosity of 40%. Sand lying below a masonry dam has a porosity of 40% and a specific gravity of 2.67. And a specific gravity of 2.67. Determine the maximum permissible upward gradient if a factor of safety 4 is considered. करिए फैक्टर ऑफ सेफ्टी क्या है, मैक्सिमम ग्रेडियंट क्या है, वो बाद में हम निकालेंगे. फर्स्ट वी विल फाइंड व्हाट इज क्रिटिकल हाइड्रोलिक ग्रेडियंट. We will find what is critical hydraulic gradient. Porosity N is 0.4, G is 2.67, factor of safety is 4. It is given to you. When N is given, you can calculate E very well. Porosity अगर से आपको दिया तो White's ratio आप निकाल सकते हैं. When N is given, you can find E. So N is equal to E upon 1 plus E. N is equal to E upon 1 plus E. So N is 0.4, E upon 1 plus E. Cross multiply karo, simplify karo. So you will get E is equal to 0.67. E is equal to 0.67. So E is 0.67 means critical gradient you needed. Critical gradient IC is equal to G minus 1 divided by 1 plus E. G minus 1 divided by 1 plus E. That is 2.67 minus 1 divided by 1 plus 0.67. So if you simplify, you will get it as 1. And the maximum permissible upward gradient is given by critical gradient divided by factor of safety. Critical gradient divided by factor of safety. That is IC is 1, factor of safety is 4, 1 by 4. It is 0.25. It is 0.25. So permissible gradient is equal to 0.25. So this is the case. Please go through the question once again. Take your time, note down it, and if you have any doubts, you can ask. As usual, you find critical gradient and divide that by factor of safety. So this is the maximum permissible gradient. Take down. So you should remember the relation between N and E always. Most of the teams, when E is given particularly, he will give E to you. Of course, in this semester you remember, but when you come to the next semester, no, you forget all basic equations. And there many times when E is needed, he will give you N. And when N is needed, he will give E. So relation between porosity and voids ratio should be clear to you. देखो एक बार और पूरा सारे स्टेप्स, कुछ नया नहीं है, सिर्फ आपको परमिसिबल ग्रेडियंट निकाला है और दैट इज इक्वल टू क्रिटिकल हाइड्रोलिक ग्रेडियंट डिवाइडेड बाय फैक्टर ऑफ सेफ्टी which is 4. Okay, so this completes the problems related to seepage pressure and critical hydrolytic gradient. So next topic I am going is called flow nets. What are flow nets? Why these are used? How these are drawn? What are its uses? You should know it. Again, this can be asked. So seepage of water through soil poses a lot of problems in the design of hydraulic or irrigation structures. Normally, the following types of answers need to be replied in this connection. What is the quantity of water that is likely to be lost by an earth dam, either as seepage through its body or as seepage from below its foundation? Next is the quantity of water seeping into the excavation which is needed to be kept dry in construction program is sometimes required to be estimated. So now the question is, as I told you, seepage pressure, seepage is a very problem for any construction. So now the question is, when seepage is there, how it is going to make the problem in construction of earthen dams particularly. What he says is, what you should know is, what is the seepage through its body. Suppose a earthen dam रहता ना ऐसा trapezoidal section में, तो उसके body में से कितना seepage होने वाला है, that you should know. So if you know all these things, then only we can design the earth dam. So seepage plays an important role while designing the earth dam. So we should know what is the seepage through its body. Second, below the foundation also, how much seepage is taking place. The quantity of water seeping into the excavation, which is needed to be kept dry. So sometimes some portion you have to keep dry, but seepage also takes place. How much that area is there. So these all things you should know before designing an earth dam. Second is, what forces will be exerted by the seepage water on the soil, and consequently what harms it can do. What harms it can do to the stability of the structure. Now, next important question is, because of seepage, there will be force, there will be pressure. So how much pressure and how much force is this much, and how it is going to harm the stability of the structure. How it is going to harm the stability of the structure. That also you should have the knowledge. Means for finding satisfactory answers to both the above types of questions, it is necessary to know the path which the seeping water follows. This path which a particle of water follows during the course of its seepage through a saturated soil mass is called flow line. It's called flow line. So what is flow net? I will tell you once again. See here, as I told you, seepage is very dangerous. And this force, this topic is totally 90% concerned with earth dam only. So when you construct, when you design an earth dam, so there will be two. One is the body of the earth dam, next is foundation. Now the question is, how much seepage is taking in the body of the earth dam? How much is taking in the body of the earth dam, and how much seepage is taking in the foundation of the earth dam? In the foundation of the earth dam. In the foundation of the earth dam. The foundation of the earth dam. Got it? So now, next question is, what pressure or what force this seepage will create on the earth dam. What pressure or what force this will create on the earth dam. Okay, so to to know about these things, how much seepage pressure is there, how it is moving, first of all we should know what the path seepage pressure is following, what the seepage flow is following path, and that particular path which it follows through a saturated is called flow line. Suppose करो ये डैम है आपका, ये पानी ऐसा होके आ रहा, so this particular path is called flow line. This particular path is called flow line. Okay, इसमें साइड में तो ज्यादा प्रॉब्लम्स नहीं है कुछ. We shall go further. So this is all the flow lines जो बनते ना, that is called flow net. Okay, so here coming it, the path which the seeping water follows has been determined with the help of the Laplacian equations and is found to be shown in the figure. The flow lines shown in this figure are the flow lines or the stream lines. The firm lines which are shown are the flow lines or stream lines. Every stripe between the two neighboring flow lines is called a flow channel. Along for flow channel, there will be a different heads. Sir, slides not visible. Now, better is slides visible night ka?
Night, sir.
Night. Ka झालं मग? थांबा 1 minute. आतापर्यंत दिसलंच नाही का तुम्हाला? का आता दिसणार नाही? आता बेटा?
Yes, sir.
Is it visible now?
Yes, sir.
Yes. Yes, sir.
So this is the figure of a dam. See here, here these lines are these thick lines are called flow lines. These lines are called flow lines, and these dashed lines are called equipotential lines. These lines are called equipotential lines, and these both lines are perpendicular to each other. The path which the seeping water flow follows has been determined with the help of the Laplacian equations and is found to be shown in the figure. That figure is there. The firm lines shown these figures are the flow lines or the stream lines. Again, I will explain once again. Every strip between the two neighboring flow lines is called as a flow channel. Along each flow line, there will be different heads of water. See, what I want to see is these lines are there, no? So this line is there. Then again, this line is there, thick line. This line is there. This line is there. All these are called flow lines. And between two flow lines, whatever the portion is there, these are called. Whatever these are called here it is given every strip between the flow channels. These are called flow channels. A line connecting all the points of equal head is called the equipotential line. The dotted lines in this figure are the equipotential lines. Every section of a flow channel between the two equipotential line is a field. So यहाँ पर देखो, मैं आपको पूरा एक बार और अच्छी तरह से बताऊं. It is obvious that any number of flow lines and equipotential can be drawn. In practice, however, only a few well spaced lines sufficient to give general picture of the flows is gone. This figure constitutes the flow net. So first of all, two types of lines are there. while we draw this earthen dam figure. So two types of lines are there. One is flow line, another is equipotential line. One is flow line, another is equipotential line. What is flow line? These lines, these firm lines are there, no? जो गाढ़े है, dark है. So these are called flow lines, and these lines which are in dotted are called equipotential lines. Equipotential lines. So now you should know what is flow line, what is equipotential line. What is flow line and what is equipotential line? Combinedly, all these will constitute the flow net. Combinedly, all these will constitute the flow line, flow net. The path which the seeping water follows has been determined with the help of the Laplacian equation and is found to be shown in the figure. The firm lines shown in this figure are the flow lines. Flow lines means the seepage pressure in which direction it takes the flow, no? That is called the flow line or the stream lines. So remember, जिस lines, जिस flow में पानी बहता seepage का, so that is called flow line or seepage line. Every strip between the two neighboring flow lines is called a flow channel. Along each flow line, there will be different heads of water. तो एक बार और याद रखो, देखिए ये है आपका फ्लो लाइन, और ये दोनों के बीच में दो फ्लो लाइन के बीच में दो फ्लो लाइन के बीच में जो भी आता, दैट इज कॉल्ड फ्लो चैनल. दैट इज कॉल्ड फ्लो चैनल. और अब ये दोनों के बीच में जो ये सारा क्या है, फ्लो चैनल है. और एक चीज याद रखो, हर एक फ्लो लाइन पे हेड ऑफ वाटर अलग अलग हो सकते हैं. इस पॉइंट पे अलग हेड ऑफ वाटर रहेगा, यहाँ पर अलग रहेगा, यहाँ पर डायरेक्शन फ्लो का ही अलग है, लेकिन हेड ऑफ वाटर हर जगह अलग अलग रहेगा. और अगर से आप a line connecting all the points of equal head is called equipotential line. अब हम क्या करते हैं, इस फ्लो लाइन में अलग अलग हेड्स है, इस फ्लो लाइन में अलग अलग हेड है, लेकिन हम हर फ्लो लाइन से ऐसे पॉइंट्स को पकड़ते जिनका हेड इक्वल है, और उस लाइन को जब हम ड्रॉ करते, इट इज कॉल्ड इक्विपोटेंशियल लाइन. इसके बाद एक 2 मिनट का ब्रेक ले लो आप. आई विल once again I will repeat the things. What is flow line, what is equipotential line, what is field, what is flow channel, and what is flow net. What is flow net? एटलीस्ट आपको, ये बहुत डीप सब्जेक्ट है, बट एटलीस्ट ऊपर ऊपर का तो आइडिया आपको होना चाहिए. तो इसके बाद एक आप ब्रेक ले लो, 2-3 मिनट का, एंड वी विल स्टार्ट द थिंग्स.